Hello everyone and welcome to another episode of the IPG and Simulink tutorial. So moving on from the last episode, what we're going to do now is use the previous model, which you should know how to open, use this previous model to change it and reflect the car that you want to create powertrain wise. There's lots of ways of doing it. You can start changing parameters of, aero components, of dynamics components, all that sort of stuff. We're more focused right now on the basis of it and making sure that the whole drivetrain and everything works as expected. So pretty much when you open the CarMaker GUI, as last time, if you saved it correctly, your whole simulation should start up. So it should be very quick for you. Just to double check, let's have a test run, and even before that, what I'll do is I'm going to run this CMNV file. Okay, so they should be linked now. They should have been linked from before as well, but 100% now. Let's open up IPG movie. I'll take that off the screen. Lovely. So if we run this now, we should get the same simulation as we got in the previous video. So it should end with about 50 odd kilometers at the end of it. Lovely. Yep, so that's fine. That's running as expected. Now, this video is going to be completely focused on playing around with your powertrain setup. Okay, so what we're going to try and do is change a couple of things, make it a bit more realistic, see how we go doing that. The first step that I like to do is change the motor characteristics and even change it up a little bit, because we want to stop having this so reliant on the controllers. Let's focus on the bare bones of getting the powertrain working properly and moving from there. So to start, the way I would be doing it is I'd actually bring this read CM dictionary variable. So I'll copy that, come out of it and paste it up here. Let's delete that. Okay, so as I said, we're going to make it very, very simple. So that should become this now. So we're getting the direct gas value. I'm actually going to take this whole process of traction control, or the controller that it uses to reduce the speed of the tires. I just want to see exactly how we can get full speed going. So in order to do that, let's have a look and bring everything down a couple of notches. So these motor maps take two separate inputs. So the first input down the bottom is going to be your gas input, and the one up the top is going to be the rotational speed of that particular motor at that point. So let's take these values here. Okay, so let's move these up. Now, pretty much what this does is it takes the speed of the wheel that IPG returns us, goes through the gear ratio that we've set in the idiff, which is in our parameters file on MATLAB, and then converts the units so that we get it into the form that's needed for the torque map. Once that happens, it then goes through this step function to give it a step response before going through the gear ratio to go from the motor torque to the real torque that you're actually providing it. So we can just copy and paste this again, move this down, okay, and connect that up. Now let's change this variable to rear right. Okay, lovely. So that's the first step. This should work. You can test it and see that it does work. We haven't done any major changes. All this is doing is just giving direct values rather than separating them using this controller that they've provided. So in terms of these 2D lookup tables, the way it looks for it is it looks for your row and column and table data using a particular link to a file, and this is a motor characteristic for the 85 that's provided. If we go to, let's have a look in our project directory, projects, tutorial 1. Okay, so let's open this up. We're provided with a define characteristics table, and this table allows you to change your values here. And if I enable editing, sorry, so let's say 21, 21, 21, and it changes the values. So you change the values in these green boxes to suit your particular motor, and it changes the values for you on your torque map. And I've done this for the particular motor package for the AMKs. You can do it for any package that you're running. It should work the same. The key thing is to save it in a text file format so that we can load this into MATLAB. So let's not save that. For the purpose of this tutorial, I've already actually done it. So I'm just going to copy and paste this into there. Lovely. So that goes in here. Okay. Now this file should come up into our MATLAB directory. Let's have a look. amkdata.gc. Now this is the fun part. So you would have noticed, oh sorry, wrong thing. You would have noticed us talking about IDIF in the Simulink model, which I'm going to bring up. Okay, so this IDIF value is a parameter that we need to set inside of MATLAB. Okay, and in order for us to set it inside of MATLAB, we obviously have to have some sort of script, unless we want to change it every single time we want to go through it. So the way that I'm going about this is we are going to load the new AMK data. AMK, what's the file name? Sorry, AMK data underscore GC dot text. Okay, so once we run this now, it should come up here. There we go, that's the newest one. And you can see it's in the same format as the other two motor characteristics files, which is perfect. That's exactly what we need. Now we are able to change all of these values to AMK data underscore GC. And let's just Control V. Apply. Okay, and you're getting that same sort of file form, same sort of shape that the other one provided us with. Lovely. So, let's do all of this. Lovely. So that is working now. So now we've got all that. Okay, and the thing that we're running now is we've got very low torques. The AMK data shows that only you've got 21 Newton meters of torque, which is not going to probably push the car at all. So we have to change these values that we're doing. And in the case of our car, I think it's a 11.923 gear ratio. Okay, let's go 11.923. Lovely. So we've got this working now. And in order to get the correct values coming back through from the transition of the wheel speeds, we're going to have to change this IDIF value inside the code here. 11.923. Let's run it again and make sure that it updates. Lovely, 11.923. So now we've got this parameters file working as we expect. We have this cmanv file that we are going to reinitiate to make sure it works. And we have all this happening here. So I'm going to save this. Yes, it will just save it into a new file format. let's go back, and have we opened CarMaker already? We actually have. Lovely. So let's run and see what happens. Should probably get RPG movie up. Sorry. That's probably why we haven't got the gas connected. Okay, lovely. So now that that's the case, we can open up RPG movie and sorry. Let's move this Simulink over the MATLAB now. Lovely. So that's exactly what we wanted to see. We now know that we're getting the correct values. That seems realistic enough. You can always cross-check it with what sort of data you're expecting. If you want to do another check, one thing I like to do is go here, let's put a scope, and we can put 2 inputs in here, just see what we're getting. It's expected that they are similar, even though they might be a little bit different. Okay. Yeah, so it's around about exactly what we're expecting in that 250 range, and you can see probably if you look at some wheel slip stuff, you'll notice the car slipping, hence why these are reducing. Perfectly understandable, no stress about that. We haven't looked at controller stuff as of yet. The main thing is just getting the model correct, and that's what the point of this video is, and pretty much awesome. Okay, now for a bit of sanity, what we can also do is inside that additional parameters being set, it isn't the biggest issue. If you give me 1 second, isn't the biggest issue for the motor characteristics, because that's coming from the actual Simulink model. But when we do start moving to all-wheel drive, this information here is extremely important. We are going to have to change this. So with that being said, let's start changing some things up and see if we can get it to all-wheel drive, see if we notice any changes in speed. So we've got to a max of 101 kilometers here. Let's have a look. The first thing I'm going to do here is we're pretty much using the same variables. Everything's running the exact same as what it should. So let's just copy and paste it. Lovely. What we're going to do is go to front left and front right. Lovely. So then we're able to go and copy and paste this once, and let's go this and connect these up. Okay, so obviously these values need to be changed. Let's change them. So front left. Any variables or values you need to know the name for can be found in the reference manuals. IPG is really good in the sense that their naming conventions are on point, so you generally won't get too much difference between like things like this. Like they wouldn't change between front left and rear, sorry, front and rear. the naming convention practically stays the same. So theoretically, this is enough. This should be able to run it, although it should be able to run, oh, sorry, no, I've changed the actual name of the bottom one. So even though we think that this should run it, we have to take into consideration, similar to the gas, the way we did the last time, is in here we now have new variables coming out of the function, and we need to assign them to something in CarMaker. So don't get this confused with the orange boxes. These do nothing. It's purely for that particular function, whereas these boxes here are what write to CarMaker. So that being said, let's do what we've been doing. Let's start variables, and let's change these up. So this is front left here, left, okay, and this is front right, okay, and that is all together. So if we save this now and we run, we should expect to see the green box here. There we go. So we did get exactly what we expected. The green box shows the power of the wheel, so the force that's acting on it in the longitudinal direction. So we are actually producing torque to the front wheels as well, which is what we're after. So that's pretty much it for this tutorial. This is now an all-wheel drive vehicle, and you can start playing around with your controller scheme. As I've said in the last video, you can run your controllers directly through this interface if that's how you were after, how you wanted to do it. The other way of doing it is through the CarMaker section. We can actually create particular plugins, and those plugins can be installed inside through here. So this model, we can add the plugin model to it. But other than that, that's pretty much it for getting the car to all-wheel drive, changing up your Simulink model, and getting it linked with IPG. So thank you everyone for watching these couple of videos. Hopefully you learnt something, and good luck with your controller design.